Welcome students for today's class. In the last class, we have seen about the development testing, and this development testing is of three types, that is unit testing, then component testing, then system testing. And in the last class, we have already discussed about the unit testing. So today we are going to see the component testing. So what do you mean by component? As discussed in the last class, in the component in the sense, you should have some composite things, okay? It means that some objects. If you are going to have some objects and if they are going to interact with each other, so what if they will interact with each other by forming or by configuring themselves, if they have already configured and if they are going to reconfigure also, then we can have the component testing in each of the objects or in each of the components, right? So here what we are going to do, we have to access only the objects whatever has been defined inside the component interface. Suppose I will give you the example. I have suppose one component, let's take it as a student component, and inside the student component there will be many objects, right? So USN, name, father's name, mother's name, mobile number, all these things are your objects. So these all are nothing but these all are the functionality of your objects. So now if you want to access all the object, then you have to define all these objects inside the component interface, and when you will merge all together and you are going to test, that is known as your testing composite components. So therefore what it is going to do, it has to be focused on your component interface. And I told you about the behavior, right, in the last class, how it is going to behave towards the specifications. So it is going to be worked out in such a way that where the behavior towards the specification will be proper. So the individual object are going to be tested individually and inside the components. If you have the composite components, then also it is going to be tested. Moving towards your next slide, the next one you can see the interface testing. So now what is that interface testing? So here what's happening, suppose if any objectives are there, if you want to detect the faults what is happening inside your interface. So faults in the sense, maybe it will have some kind of your errors, or maybe it will have some kind of your invalid assumptions. So if it is having some kind of your faults or errors or bugs or invalid assumptions, then your objective is to find it out through your testing, and you are going to rectify the errors. So now here some of the types are there, like that is called as your interface type. And by using this interface type, you are going to detect all the errors whatever has been happened inside your interfaces. So now the first interface types are parameter interface. So now what is that parameter interface? So inside the parameter, inside the function we used to pass the parameters. Suppose I have like name. So if my name will be a function, what are the parameters I can pass inside that? I can write the string. So whatever the name I'm going to pass, that can be a string. So here what I have written, the data has been passed from one method to procedure to another. It means whenever you are sending the data, that has to be string only. So in your name function, if any parameter you have passed or methods, so that has to be string. Okay, so the data whatever I have been passed from one place to another place, that is known as that work has to be done inside your parameter interface. What is the next one interface type? That is your shared memory interface. What it is going to happen in your shared memory interface? Inside that, in our memory, there will be a block of memory, okay, in the system, where whatever the memory space we have, everything has been stored in the form of your blocks. So blocks in the sense, you can say that it is a individual procedures or instructions, or you can say it is a kind of your functions. So all these things has been shared inside the block of memory. So that is also a kind of your shared memory interface. The next one you can see the procedural interfaces. So what is happening here? The subsystems encapsulates a set of procedures to be called by other subsystems. It means that procedure in the sense you are writing some code or if you are giving some kind of your instructions, then one instruction has to follow the next instruction. So the first instruction will be encapsulated with some of the other instructions, which is also known as your sub instructions. So that can be called to your subsystems. That is nothing but that is your procedural interfaces. The last one is nothing but message passing interface. What you are going to do in the message passing interface, inside that you have to send one request, you have to request the service, then you have to get the response back. So whenever you are sending any request, you have to send it through your subsystems, and through that only you are going to pass a message from one system to another system, and the another system, that is your destination side, it is going to send you the response back. That is known as your message passing interface. So now what we have learned from here, there are some interface type, which is known as your parameter, shared memory, procedural, and the message passing interfaces. So if any kind of errors or any kind of invalid assumptions or any kind of bugs or faults happens in between these interfaces, so it is going to be detected as soon as possible, or you can apply the testing method to find out the errors. So these all are the objectives of your interface testing to detect the faults. Moving towards the next slide, we have the diagram over here. You can see there will be the test cases. Whenever there will be some test cases, it has to be it has to pass like a module wise. So in this case, like A has been given the request or passed through this and given the response back. And also one more time, if it is going to for the checking, then it can send the data to C. So this is a diagram just to have a look into this and just to understand the procedure, how the interface testing is working out. This is a diagram for that. Now we can see what all are the interface errors. So there will be some kind of errors. I told you already that some errors, the objective of this interface will be finding out the errors. So now what all are the variety of errors are present? The first type of your error is interface misuse. So now what is that interface misuse? We have already seen there are many varieties of interface types are there. So if any component or subsystems are calling to the another subsystem, then that time if that is not present or if it is not in order process, then what will happen, if we can say that we are calling to a wrong components or we are calling to a wrong subsystem, that time we are misutilizing the interface. So that is a kind of error which will occur when we have done the testing procedure. The next one you can see, that is your interface misunderstanding. What happens in interface misunderstanding? When we are, suppose if you have one component which has been embedded with another component, embedded in the sense inside the one component, if you have given any button or something, if you are clicking on that, then one more window will open or one more activity will start. That is known as your embedded system. Okay, so here what you are going to do is you should have the components or subsystem which has been already embedded. So you know that if I will click on that, I should get this kind of activity. But due to some behavioral projections and all, so what will happen? That component will be incorrect. So it will not open the assumptions whatever we have prescribed. So that is known as your interface misunderstanding. That is a kind of your error. What is the next one? Next one you can see that timing errors. What is the timing errors now? The timings errors will be, suppose if I have passed the request or if I have called for the message to my one place to another place, there will be some limited time, and within that time period I should get back the response or the message has to be reached like from source to destination side. So the speed and the performance, if it will not be within the time period, then we can say that that is a timing error. So these all are the variety of interface errors, what all are present and how we are going to detect the faults. So moving towards the next one, here some guidelines are there to achieve our interface testing. So here the first guideline is design test so that the parameters to a called procedure are at the extreme ends of their ranges. It means that if you are calling for a parameter, you have to prescribe some of the range, that within that range my procedure has to be worked out, so that it won't give any kind of the faults. So that is one kind of guidelines which has to be followed inside our design test. The next one is like always test pointer parameters with null pointers. So what will happen here, whenever we are testing and pointing towards the next stage to go forward, that time we have to give as a null pointer. So if you are giving the null pointer, we can understand that there only the testing procedure has to wind it up. So if it won't be, so it will add that null pointer value and it will give you the wrong or fault value. That's the reason we have to avoid all these things. Next will be the design test which cause the component to fail. So sometimes what happens is, whatever the design we have done for any of the product, sometimes what will happen when we will go for the checking individually for any kind of your object or component, it used to fall into the like it used to fail because the design is not proper or design test has not made properly. So that also has to be a guideline to, before going for the component testing, it has to be, the test cases has to be proper. Next one will be use stress testing in message passing system. It means that the timing errors how we have got. So to avoid all the timing errors and all, we have to pass the message within the time period, and we should have the delivery of message in order. Last one is like in shared memory system, which is vary the order in which the components has to be activated. It means that if you have shared memory system, it means suppose you have 200 GB of data, 200 GB of memory space, and you have shared it with some of the systems. I suppose some 100 and 100, so you have some two system. So if you want to activate the components in one system, then you have to vary the same thing in the other system also. That is known as your shared memory system. So this kind of some guidelines are given which has to be followed inside your interface testing. The next one is your system testing. That is the last testing procedure of your development testing. So let's understand what is your system testing. The system testing during the development time involves integrating components to create a version of the system and then testing the integrated system. It means that the system testing has to start working once the component testing will be done. So in the component testing, whatever we have done, we have not checked the version of the system. We have just checked all the objects, all the module differently according to the components, how it is going to be very supportive. So once that has been done, if you want to integrate or if you want to increase the upgrade the version of that, then you need to go for the system testing and you have to focus on the interactions between the components, how it is happening and all, and how much compatible it is for all the data whatever has been given, and how it is going to be work out in other platforms whenever we will transfer the data from one system to another system. So all this emerging behavior towards your system is going to cause for your system testing. So before upgrading any kind of your platform or system, we should have to go for the system testing. That is a brief about your system testing. Now, what is the meaning of your system and component testing if it merged together? So in system testing, we are reusing the components that we have to keep in mind. We are going to reuse the components which has been already been developed. Okay, we are not, if any new developed components are there, then we have to go for the component testing individually, and we are going to add it or merge it inside the system testing. But some of the components will be available where we are going to reuse it and we can reuse separately, and at last once the new components has been tested, we can merge together and can go for the system testing. But in components, all the components whatever has been developed, everything has been developed by the developers, or you can say by the team members, or you can say the sub team members, right? So here what is happening, the system testing will be the collection of all the individual process whatever has been present inside the system. So in some of the companies, what will happen, there will be no involvement of any of the designers or programmers or developers. So that time the testing team has to work very separately, and they are going to give the output or tested output towards the system. Moving towards the next one, that is the use case testing. And in use case testing, what used to, because you have the difference between unit test casing, unit test and use case testing. So what is now use case testing? So here you can see developed to identify the system interactions which can be used for your system testing. Okay, so the use cases has been developed to identify what all are the interactions are going on in between your system testing. So that is the reason we have developed the use case testing. And also one more thing also will happen here, that is each use case will have the several system components which has to be forcefully check or interact in between them, and they have to find it out that what is exactly happening in between the components. And there will be some sequence diagram which has been associated with your use case documents. I hope you have remembered we have already done the use case diagrams, sequence diagrams. So it has to follow exactly, the testing procedure has to follow exactly whatever we have done in our use case diagrams. Here you can see the example. I feel you all have remembered about this. So this is the sequence chart. Okay, so I'll not go detail about that because already we have discussed uh, about this kind of diagram. This is your sequence chart, and all the object components are there, how they are sending the request and how they are going to get back the responses. So this is nothing but this is your sequence chart. So what is happening actually, how you can derive the test cases from your sequence diagram? That question will arise. Suppose one test cases will be the input of a request of for a report should have an associated acknowledgement. It means that whenever we are requesting for a report, the acknowledgement also can come back that we have received your request or something like that. So whenever we are asking something towards the system, it has to give the reply. So once the request has gone, the reply has to come back. A report should ultimately be returned from the request. Okay, so once the response will come back, then only we can go for the next request. So this is a problem. This is a problem like which this is a use case where we are going to find out the solution for this. So we have to test in such a way that in this use case, whenever we have sent the request for the report, the acknowledgement has to come back. Similarly, one more is also there. An input request for a report to weather station results in a summarized report being generated. It means whenever we have requested the report for the weather station, okay, so what's the reply has to come? The reply has to come the all the summarized report whatever has been collected or generated before, it has to merge everything and it should show us the reply in that way. So if it is not happening in that way, it is unable to merge all the components whatever is there, then it means that it has been failure. So it has to give the expectation output will be that it will merge all the reports whatever has been generated before and it's going to show the result. If it is not happening in that case, it means the test cases has been failed and you are going to send back this module to the developer to test, to develop it once again. So this is one kind of your test cases derived from your sequence diagram. So there will be some policies which we have to follow whenever we will go for the testing. So what all are the policies will be there? There is a exhaustive system testing which is impossible. So testing policies has to test whenever it is going to be developed. Okay, whenever the developer will develop, if sequentially we will go for all the developing one module test things, if we will go for all the modules testing, then we can have some clear idea that where is the real fault happening. So we can reduce that kind of faults before going for the next level of testing. So here some of the examples are there for the testing policies. So the first one is all system functions that are accessed through menus should be tested. It means that in the menu, whatever the individual functions will be there, everything has to be tested properly. So that individual functions will work like your modules. So individual modules has to be tested before going for any of the policies. And also it will be a combination of functions and that are accessed through the same menus must be tested. If you have provided any kind of your functions or sub functions, so everything has to be tested properly. So the user's input, if it has been provided, then that also all functions has to be tested. So these all are the some of the testing policies are available which has to be gone, which has to be utilized properly before going for the next level of testing. So this is all about your development testing, including the last class session. Today I have covered it till your component testing and system testing. So mostly you are going to get the question to derive your development testing with all the testing strategies, how you are going to choose it and how you are going to do it. So these all are everything about your development testing. Thank you.